Hey everyone, and welcome to another deep dive with us. Today we're going to Mercury.
Oh, cool.
Yeah, the closest planet to the sun,
Wow.
and we're going to investigate some really strange features called hollows.
Yeah. Okay.
They're not like your normal craters or anything. These are unique to Mercury,
Right.
and scientists are still trying to figure out like what causes them.
It's a real mystery, isn't it?
Yeah, a real puzzle. And to help us solve it, we're going to be looking at this fascinating article from NASA Science. It's called Mercury's Strange Hollows.
Oh, that's cool. I like that title.
Yeah, it's pretty catchy, and it's got some awesome images and insights from the scientists who are studying these things.
Great.
So to understand these hollows, let's go back in time to the 1970s.
Okay. Back when disco was king.
Haha, yeah. When Mariner 10 made its first flyby past Mercury.
Wow, 1970s. That's like ancient history when it comes to space exploration.
I know, right? But those first images, they were grainy and everything, but they revealed something really strange.
Like,
Well, even with those limited images, scientists noticed these unusual bright patches inside some of Mercury's craters.
interesting. But they needed to get a closer look, right?
Exactly. And that's where NASA's Messenger mission comes in.
Yes, messenger.
Yeah, this spacecraft, it orbited Mercury from 2011 to 2015, and it totally changed the game. I mean, it sent back thousands of high-resolution images.
That's awesome.
And those bright patches, they became much clearer.
So what did they find?
Well, scientists, they name these patches hollows. And they're unlike anything we've seen anywhere else in the solar system.
Really?
Yeah, and they have this almost otherworldly appearance.
I've seen some of the pictures. They look kind of eerie.
Yeah, they do. Some images from the Sandra crater show them glowing bright blue against the surrounding landscape.
Wow. Bright blue.
Yeah, it's pretty striking.
Is that blue color like a clue to what they're made of?
It could be, yeah. The visual difference suggests that these hollows are made of something different from the surrounding rock.
Okay, that makes sense.
And here's where it gets really fascinating. Those hollows are incredibly young compared to the rest of Mercury's surface.
Oh, how young are we talking?
Maybe like 100,000 years old.
100,000 years. That sounds pretty old to me.
Well, geologically speaking, that's incredibly young. I mean, most of Mercury's surface is billions of years old.
Oh, wow. So that means
So the fact that these hollows are so recent tells us that Mercury is still geologically active.
it's not just a dead, unchanging world.
Yeah, exactly. It's like you're seeing geological processes happening right now.
That's mind-blowing.
I know, right? So how did these hollows form? I mean, they didn't just magically appear, did they?
Right, haha. Well, scientists have a few leading theories, and one of them involves some pretty violent events.
Oh.
Yeah, Carolyn Ernst, a scientist who worked on the Messenger mission, she suggests that these hollows might be linked to peak rings.
Peak rings. What are those?
So peak rings are formed during like massive impact events.
Okay.
You know, picture a giant asteroid slamming into Mercury.
Oh, wow. Okay, I get it. Huge impact.
Yeah, and the force of that impact is so immense that it forces material up from deep within Mercury's crust, and it forms like a ring-shaped mountain around the crater.
So it's like a planetary burp exposing material from deep inside.
Haha. Yeah, that's a great way to put it. And Ernst's theory is that this freshly exposed material might be the key to understanding the hollows.
Okay, I'm intrigued, but how does exposed material turn into these hollows?
That's the million-dollar question. That's where another theory comes in, and this one focuses on the brutal conditions on Mercury.
Oh, right. Mercury's like right next to the sun.
Yeah, exactly. We're talking intense heat, constant bombardment by solar wind, and a steady stream of micrometeoroids.
So Mercury's basically getting sandblasted by space itself.
Pretty much. David Blewett, another messenger scientist, he thinks these harsh conditions could be the culprit.
Okay, so what's his theory?
Well, his theory is that the heat, the solar wind, and those tiny micrometeoroids, they're slowly vaporizing certain minerals on Mercury's surface.
Interesting. Does that mean certain minerals are more susceptible to this process?
Yes, particularly minerals containing sulfur.
Okay.
As those minerals vaporize, they leave behind a weaker, more porous rock, which is then much easier to erode.
So it's not so much that the hollows are dug out, but more like they're being slowly etched out by these forces.
Exactly. It's a process of slow and steady erosion driven by Mercury's extreme environment. But there's another intriguing theory that we'll explore after, well, we'll just explore it now. So this other theory, it involves something you might not expect to find on a planet like Mercury.
Oh. What's that?
Graphite.
A graphite? Like what's in pencils?
Yeah, exactly.
Huh, okay. But how does graphite, fit into this whole mystery of the hollows?
Well, some scientists think that those darker areas we see on Mercury's surface might actually be huge deposits of graphite.
Wow, that's pretty wild, but how do they turn into hollows?
So the theory is that when the solar wind, it hits these graphite deposits, it blasts them apart, like at an atomic level.
Okay.
And as the graphite disappears, it could leave behind these bright, hollowed out areas.
So the graphite is almost like a temporary scaffold that gets eroded away and then leaves the hollows behind.
Yeah, that's a great way to think about it. It's a really fascinating idea, and it just shows how much we still don't know about Mercury.
It really does, yeah. So we've got these three main theories, right? The violent impacts exposing new material, the sun and space weather slowly etching them out, and this idea of graphite deposits disappearing.
Right.
Are there any other clues that could help us figure out which one's the most likely?
Well, one of the most interesting things about these hollows is where they're found.
Yeah.
They're not just scattered randomly across the surface.
Okay.
We see a strong connection between the hollows and areas that are rich in certain minerals,
Like what kind of mineral?
particularly those containing sulfur.
That kind of supports the theory about solar wind vaporizing the minerals and creating the hollows, doesn't it?
Yeah, it does. The fact that hollows are usually found in areas with these volatile minerals suggests there's a link between what they're made of and how they form.
Makes sense.
And that's where the observations from Messenger are so valuable.
Right, we talked about those high-resolution images, but Messenger also had instruments to analyze the chemical makeup of the surface, right?
Exactly.
So what did they find?
Well, one of the most notable findings was that there were unusually high levels of magnesium and calcium in the hollows.
Huh, interesting. Are those elements rare on Mercury?
It's not that they're rare, but they seem to be concentrated in the hollows,
Right.
which suggests that maybe they're a byproduct of whatever process is creating the hollows.
So the hollows are almost like chemical filters concentrating certain elements.
Yeah, you could think of it that way.
So what could that tell us about how they form?
It's another piece of the puzzle. And then there's the role of micrometeoroids.
Right, those tiny space dust particles.
Yeah, they're constantly bombarding Mercury.
And we know they play a role in shaping the planet's surface, but how could they be contributing to the hollows?
Well, some models suggest that micrometeoroids might actually be the main erosive force gradually carving out the hollows over time. Others propose that they play a more subtle role, maybe breaking down the surface and making it more susceptible to other erosive processes.
So it's still not clear whether they're the main sculptors or just kind of the cleanup crew.
Yeah, pretty much.
This is all so fascinating, but I'm also curious about what these hollows might tell us about the future of exploring Mercury.
Oh, that's a great point.
Like, what could we learn from actually landing a spacecraft on Mercury?
Well, a lander would allow us to actually study these hollows up close.
Yeah.
We could analyze their composition in even greater detail and maybe even witness their formation in real time.
That'd be amazing.
Yeah.
Like watching a slow-motion geological fireworks show.
Uh-huh.
Exactly. What else could we learn?
Well, we could answer those key questions about the role of micrometeoroids and whether the hollows are still actively forming today.
Right.
And speaking of active processes, a lander could also help us investigate a possible connection between the hollows and something else we haven't talked about yet.
What's that?
Water ice?
Wait, water ice on Mercury. But isn't Mercury like the closest planet to the sun?
It is, but Mercury actually has frozen water in permanently shadowed craters at its poles.
Oh, really? I didn't know that.
Yeah. Because of the planet's axial tilt, those crater floors never see sunlight.
So they're like giant cosmic freezers.
Uh-huh, yeah.
But how is that even possible with all that heat from the sun?
It's because of those deep craters and the lack of direct sunlight. The temperatures in those permanently shadowed regions stay incredibly low, cold enough for water ice to survive for billions of years.
Wow, that's incredible. Okay, so there's water ice on Mercury, and it's potentially connected to these hollows. How?
It's not a direct connection, but it's possible that whatever creates hollows might also contribute to the stability of those ice deposits.
Okay.
Remember that constant bombardment from the solar wind and micrometeoroids?
All right, the forces that could be etching out those hollows.
Well, that bombardment also churns up the surface, creating a layer of loose material called regolith, and that regolith acts like a blanket, insulating the ice deposits from the sun's heat.
So the same forces that create the hollows might also be helping to preserve a valuable resource for future exploration.
Right.
But what about life? Any chance we could find anything living in those extreme conditions?
That's a great question. And while the hollows themselves aren't really a sign of life, they do give us valuable insights into what conditions are necessary for life to exist.
So by studying how these forces shape Mercury's surface, we can learn more about the limits of life as we know it.
Exactly. And maybe even expand our definition of what a habitable environment
Hmm.
is.
That's a great point.
Uh,
Okay, so we've been talking about these mysterious hollows on Mercury, and it makes me wonder what they might tell us about life beyond Earth.
Hmm.
I mean, Mercury seems like the last place you'd expect to find anything living, right?
Well, it might seem that way, but life is, it's incredibly adaptable.
Yeah.
I mean, we've found organisms here on Earth called extremophiles.
Extremophiles.
Yeah, they thrive in all sorts of harsh environments.
Like what kind of environments?
Well, places like boiling hot springs or acidic lakes, even deep beneath the ocean floor.
So these extremophiles, they prove that life can exist in conditions that would be deadly to us.
Right.
So does that mean we could find something similar in Mercury's hollows?
Well, it's probably unlikely that we'd find like complex life forms, in those extreme conditions.
Right.
But studying extremophiles, it really helps us understand what's possible.
So instead of little green men, we might be looking for microscopic life forms that
Yeah.
have adapted to Mercury's intense heat, the radiation, and that constant bombardment.
Exactly. And those adaptations could give us clues about the potential for life on other planets and moons.
That might seem inhospitable at first.
Right.
So it's like Mercury is a natural laboratory for studying the limits of life.
Yeah.
So even though we might not find life in the hollows themselves, they could still teach us a lot about where to look for it elsewhere in the universe. That brings us back to sending a lander to Mercury.
Yeah.
What are some of the biggest challenges in actually getting a lander on the surface?
Well, landing on Mercury is, it's really difficult.
Yeah.
It's a small planet with a weak gravitational pull.
Okay.
So a spacecraft has to approach very precisely to avoid being flung back into space.
Right.
And then there's the intense heat and radiation from the sun.
So it's a real engineering challenge.
It is.
But imagine the rewards if we could pull it off. What would be at the top of your list for a Mercury lander mission?
For me, it would be to land near one of those permanently shadowed craters where that water ice is.
Oh, yeah.
A lander could drill into the ice and analyze its composition.
And that could tell us about the history of water in the solar system.
Exactly.
That's amazing. And it's something that only a lander could do.
Right.
It feels like we've only just scratched the surface of understanding Mercury in these incredible hollows.
We have, and the best part is there's still so much more to learn. Future missions like Bepi Colombo, it's actually on its way to Mercury right now.
Oh, wow.
It'll provide even more detailed observations and hopefully help pave the way for a future lander mission.
Well, this deep dive has been incredible. It's really opened my eyes to the wonders of Mercury and all the mysteries it holds.
Yeah.
From these strange hollows to the potential for water ice and clues about the search for life beyond Earth. Mercury is a planet full of surprises.
It really is, and it reminds us that there's always more to discover, even in the most unexpected places.
Absolutely. Well, thanks for joining us on this journey to Mercury. We hope you enjoyed this deep dive into, the heart of a planetary mystery.
It was my pleasure.
And if you're as fascinated by these hollows as we are, be sure to check out that NASA Science article we mentioned.
Yeah, Mercury's strange hollows.
Yeah, it's full of amazing images and insights. Until next time, keep exploring